Welcome to Chilling with Miss Miller, where our motto is filling Algebra 2 problems in a chillin' way. With our cool co-host, Crystal, welcome to and enjoy the show.
Okay. Oh, did I interrupt the dancing?
Yeah.
Woo! You want to keep going?
No, it's okay.
All right, here we go. Today we are starting a new chapter, and I will warn you all. Warn you all ahead of time that this chapter is a little bit longer than previous chapters, which is a good thing if you look at it a certain way, and not if you look at it a different way. So here we go. What's up, Zach?
It's still review.
Yes, still review. Let's give it up for the fact that it's still review of Algebra 1.
Going into Algebra 2.
When did it stop being review?
Next semester.
Alrighty.
Okay, here we go. All right, here we go. It is raining again today, and people are...
I love it.
It was raining.
Yeah, it's in and out. Okay, here we go. So, a monomial. Let's keep this simple. A monomial is one term. So what I'm going to do is I'm going to write something up here. 7x cubed minus 11x squared plus 8x minus 17. And I'm going to label in here a bunch of monomials. So, this is a monomial. Everybody write this down. Monomial. That is a monomial. This is a monomial. Monomial.
One term.
Exactly, one term. And that is also a monomial. So, if each of these individual one terms are all put together, like they are here, we have what's called a polynomial. So, if somebody could break down the word polynomial, what do we think? Salone.
Two terms.
Okay, is it just two? Poly is a prefix for...
Many terms.
Many. All right, everybody give it up for Sloan. Multiple terms. Okay, cool. So, up above, all of these combined make up a giant polynomial. So, a bunch of monomials put together make up one giant polynomial. All right, then the last piece is like terms. I'm hearing a lot in our audience. I'm hearing a lot of, oh, I remember this. Oh, this looks familiar. It should. It's Algebra 1 stuff. So, all right, like terms. What are like terms? Tyler.
Terms that like have the same exponents or no, or not exponents, like just
You're
the
right.
same like letter. or
That's
symbol.
excellent. Everybody give it up for Tyler. Hey. So, like terms are terms that have the same letter or combination of letters. Okay, so I'm going to put up a couple examples here. Or combination of letters. So I will say this. The chapter that we're working on right now is probably the most important or one of the most important chapters that we will do all year. Clap if you think you might want to go to pre-calculus next year. Clap. Clap. Make noise. Okay. Clap if after that you would like to go to calculus. All right, cool. So this is one of those that you are going to need for every level of math beyond this. So this is a really important chapter. All right, so let's put this up here. 8x and 11x are like terms. Somebody tell me why 8x and 11x are like terms. Thane.
They both have X.
They both have x. Give it up for Thane. That's the worst giving it up ever. Okay, so now, can somebody give me another pair of like terms? Super delayed announcements. Be right back. Somebody give me another pair of like terms. Get creative with the letters that you're using. Cole?
74p
Uh-huh.
and -7p.
All right, everybody give it up for Cole. 74p and negative 74p. All right, what if I do, well, actually, you guys tell me. Others? Rebecca? And then Aiden, I'm going to get you next.
8 ABD
Uh-huh.
and 17 ABD.
All right, give it up for Rebecca. Everybody give it up for Rebecca. Aiden?
6 PFAA.
Oh, all right.
That should be
Although,
A squared.
yes, shouldn't it be PFA squared?
PFA squared, my bad.
PFA squared. Oh, I like it. Okay, and what?
9 PFA squared.
9 PFA squared. All right, everybody give it up for Aiden. Nicely done. Okay, Zach, last one.
12 ZACH.
Oh.
And 18 ZACH.
All right, everybody give it up for Zach. We have, so if we have 12 Zachs and 18 Zachs, if we combine those 12 and 18 Zachs together, how many Zachs do we have? 30 Zachs. All right. So here we go. That was awesome. Okay.
I can't.
So for the specified function, now we're going into examples. P of x equals negative 5x squared plus 7x. We want to find P of 3, P of negative 1, and P of a. Find P of negative 1 and find P of a. What's the matter? We haven't done anything with them yet. How can you already not like them?
But she's shitty.
All right. So, anyone have any ideas? We want to find, yes, negative 5x squared. Lorenzo?
You just plug it in.
Good. So if we want to find P of 3, we plug what in where?
You plug in the 3 into the x's.
Excellent. Plug the 3 into the x's. Everybody give it up for Lorenzo. All right. So if I look at this, I go negative 5 times 3 is negative 15, and negative 15 squared is 225, right? Am I right?
Yes.
Dude, you all just walked right into my trap.
No.
Why do you not do that? No, now we're changing our mind. Why do you not do multiplying and then the exponent? Taylor? That's good, exactly. Everybody give it up for Taylor. Now, let me repeat what you just said. The only thing that's squared here is the 3. And if we want to go back to PEMDAS. Exponents happen before multiply. So 3 squared is what? 9. 9 times negative 5? Negative 45. What is 7 times 3?
21.
21. Okay, what is negative 45 plus 21?
Negative 24.
Excellent. Okay, everybody give it up for everybody who just did all of that. Woo! All right, how about the next one? If I want to find P of negative 1, now what do I plug in? Where? Somebody read to me what it should look like. Taylor? Oh, Michael, I'll get you the next one.
Negative 5 is negative 1 squared plus 7 times negative 1.
All right, everybody give it up for Taylor. How about everybody give it up for Taylor? Where are all of us? Okay, so here we go. Negative 1 squared is what?
1.
1. Positive 1. A negative times a negative is a positive. 7 times negative 1 is?
Negative 7.
Negative 7. So we get negative 5 minus 7, which is how much? All right, everybody give it up for yourselves. Interesting how that's the most enthusiastic version. Okay, last one. Michael, what am I plugging in now? All right, everybody give it up for Michael. All right, questions?
Wait, I'm not done.
All right, let's move on. I will leave this up here, don't worry. Okay, so the next one. These should be pretty easy. I guess you'll all tell me whether they actually are or not. All right, combine like terms. Like terms. Okay, so the first one, we've got negative 2y squared minus 7y squared plus 5y squared. We want to combine those like terms. Negative 2y squared minus 7y squared plus 5y squared. All right. Combine like terms. What do we think? Aiden?
Negative 2y squared minus 7y squared equal negative 9y squared.
Excellent. Negative 9y squared plus 5y squared is what?
Negative 4y squared.
Cool. Everybody give it up for Aiden. All right. Now, what about, we can do as many or as little of these as you all like. 4a minus 9b minus 6a plus 3b. So 4a minus 9b minus 6a plus 3b. All right. Can somebody identify any like terms within this polynomial? Sloan and then Thane. Sloan, pick one. Go ahead.
4a and negative 6.
Cool. What makes those like terms? The a's. Good. So 4a minus 6a is how many, Sloan?
Negative 2.
All right. Everybody give it up for Sloan. Nicely done. All right. Thane is going to give us another one. What's another pair of like terms here?
Negative 9b and 3b
Uh-huh.
and negative. No, wait, no. What was
Yep.
that? Negative 2.
So negative 9 plus 3.
Negative 9 plus 3, that would be negative 6.
Excellent. Everybody give it up for Thane. Nicely done. Okay. Last example. Ready?
Yes.
That better not be a phone.
It's
Okay.
a very fancy calculator.
You guys ready for this? This is really long. For p of x equals 11x to the 5th minus 7x to the 4th minus 10x cubed plus 13x squared minus 16x plus 61. And I have terrified them. And q of x equals 43x to the 5th minus 30x. You all should make your biggest scary noises, like you're all freaked out.
The
Oh
zombie.
my. The zombie speaks for itself. Yes, true.
That's distracting me.
Wait.
I don't think I can do math with that thing. It's just.
70. All right. Whoop.
Wait.
Sorry about that, you guys. It's awful.
Is this? Hold on. Is the 11x? Is that on the other side?
No, no. It's all supposed to be on the left side, but it's going to be too confusing to try and fit it in. So,
Oh.
wait. Let's not do questions until we see what we're supposed to do with these. Okay.
Wait.
We want to find p of x plus q of x. And then we want to find p of x minus q of x. This is not difficult. I promise. It looks like it's going to be, but it's not.
Don't overcomplicate.
That's true. Good. Everybody give it up for Crystal with her
Yeah,
comment. Don't
Crystal.
overcomplicate. Yay! Okay. So, p of x plus q of x. Anybody have any ideas? What are they asking us to do with these very long, horrendous equations? What are they asking us to do? Aiden?
Basically, like what we did in the last unit.
Mhm.
We had this kind of problem. We put them together.
Good. Why? How do you know you put them together?
So it's on.
Because what?
I don't remember.
Okay, what does it say here?
Oh, yeah, put them together.
To put it, that tells us in the directions to add them together. So we literally, fortunately for us, the x to the 5ths are lined up. The x to the 4ths are also lined up. So are the x cubed, so we can add straight down. So if we add straight down, who can tell me what we end up getting? Jonathan.
The first one would be 54 x to the 5th.
Good. Next one.
Minus 37x to the 4th
Excellent.
plus 8x to the 3rd
Excellent.
minus 13x squared.
Excellent. What happens to these?
They cancel out.
They go away, so we don't even need an x in there. And then,
plus 131.
excellent. Everybody give it up for Jonathan. Yay. Okay, last example. Now, with these two polynomials, we want to subtract q of x from p of x. Okay, if I subtract q of x from p of x, what that's saying is I'm subtracting this whole entire expression from what's above. What does that mean as far as this negative? What do I have to do with the negative? Distribute it. And what does the negative being distributed do to the signs of each of these terms? It changes them. Perfect. Okay, give it up for yourselves on that. That was awesome. Okay, so this is a minus. This one is a plus. I'm going to make these huge so you all know what's happening. This one is a minus. This one is a plus. This one comes out to be a minus, and this one is also a minus. Make sure that they're big enough so you all can see them. Plus. That's pretty good. Okay, so now, and then we do the same thing as we did in the last problem. So does somebody want to tell me when I combine these, what I end up getting? So 11x to the 5th minus 43x to the 5th. Aiden?
Yeah, 32x to the 5th.
Negative 32. Excellent. Okay, what about 7 minus, negative 7 plus 30?
You get 27x. No, 23x.
That's perfect. Okay. Negative 10 minus 18?
You get negative 28x to the 3rd.
Perfect. 13 plus 27?
You get 40x to the x squared.
Good. Negative 16 minus 16?
You get negative 32x.
Good. And then 61 minus 70?
You get you get 9. Negative 9.
Negative 9. Good. Okay. Everybody give it up for Aiden. Okay. How are we doing on questions? Yes, Liz.
So on number 2,
Uh-huh.
you switch their signs, and if they were first positive, now you make them to a negative.
Exactly. Perfect. So if it says subtract, we switch all the signs of each of the terms. And then, yeah, exactly. Yep. Other questions? Okay. You guys have a homework assignment. It is homework 26, page 208, numbers 1 to 21 odd, and 37 to 43 odd. Oops, we are fading out. All right. Everybody take us away.
Hot hand.